We'll now continue our discussion of section 5.3, logarithmic functions. We begin with a continuation of our definition for a logarithmic function. In equation form, the definition of logarithm means that the equations a is equal to y to the x and y is equal to log base a of x are equivalent. Note that a is the base in both equations, either the base of the exponential function or the base of the logarithmic function. So what this does is it gives us a definition for the relationship between the logarithmic function and the exponential function and gives us a way to convert in between the two formats. So this statement is very important that we understand and remember so that we can change a problem from exponential to logarithmic and from logarithmic to exponential. So let's practice this. We're going to use the definition of a logarithmic function to rewrite the following exponential equations as logarithmic equations. So I'm going to write that statement at the top here so that we can use it. It said that y is equal to log base a of x was the same as x is equal to a to the y. So what you want to keep in mind here is that this is a simple rearrangement of terms. So if I'm going to write 8 is equal to 2 to the third as a logarithmic equation, then what I want to do is I want to write the word log down, and I want to go ahead and fill in the base. So remember that the base is, in the exponential function, the part that is raised to the power. So the base is going to be 2, and the base in the log function is going to be the subscript. All right. The exponent in the exponential function is going to be the part on the side of the equal sign away from the log. So we're going to put the 3 over here. And then the 8 will go in the spot that's left. So you can think of it like a rearrangement of terms. The easiest way to do it is to think of it like a pattern. And so if you'll start with your base, so your base is 2. You need to go to the other side of the equation to get the exponent. So that would make 2 to the third, which is what we have right here. And then we're going to set it equal to the piece that's left. All right, so you may find that the second set of problems is a little bit easier to work with first. So why don't we try that, and then we'll come back and deal with the other two. So rewrite the following logarithmic equations as exponential equations. So we're going to start with the base. So log base 3 of 9 is equal to 2. What part of that is the base? The base is the subscript, so we'll start with 3. Remember, you're going to go to the other side of the equation to get the exponent. So 3 squared. And then you're going to set it equal to whatever is left. So we have used the 3, we've used the 2, we have the 9 left. So 3 squared is equal to 9 is the equivalent exponential equation. All right, so what about part E? 3 is equal to log base 8 of 512. So start with your base, which is 8. Go to the other side and get your exponent. And then set it equal to the part that's left. So equal to the 512. All right, part C. Y is equal to log base 2 of x. Start with your base. Go to the other side and get your exponent. Set it equal to the part that's left. So 2 to the y is equal to x. All right, so let's come back up and see if we can fill in B and C then. All right, so we are going to, we have 5 to the 4th is equal to 625. So your base is what? Right, your base is going to be 5. Remember that you would want to go to the other side for your exponent. So on the other side, we would have the 4. And then the 625 would go in the spot that's left. Part C, 7 to the x is equal to z. So we'll write the word log down. We'll put our equal sign. What's our base? 7. Remember, we want to go to the other side for the exponent. So the x should be on the other side. And the z should be in the spot that's left. So you want to practice this until you can very easily convert between your logarithmic and your exponential formats. Being able to convert will help you to solve logarithmic expressions. So our next example is asking us to, for part A, to solve log base 5 of 25. So the easiest way to do this is to take your expression and set it equal to x. We're setting it equal to x because we're trying to figure out what it's equal to, and we don't know, and our unknowns are usually x's. Once that's done, you want to change it to exponential form. So you want to start with your base, which is 5. You want to go to the other side and get your exponent, which is the x, and set it equal to 25. Now, sometimes at this point, you can just figure out what the x has to be. I think in this case, we definitely could do that. 5 to what power is 25? We know that 5 squared is 25. So x is going to equal 2. So log base 5 of 25 is equal to 2. All right, let's move on to our next one. Log base 1/2 of 2. We're going to set it equal to x. We're going to write it in exponential form. So start with your base. So 1/2. Go to the other side and get your exponent. And set it equal to what's left. So 1/2 to the x is equal to 2. So what we know is that if we took this 1/2 and instead brought the 2 up to the top, it would cause that exponent to become negative. So I could rewrite this as 2 to the negative x is equal to 2. Now, if we have 2 to the negative x is equal to 2, this is an x to the 2 to the first. So remember that when we're solving this exponential equation, which is what it is at this point, once our bases are alike, then we can set our exponents equal to each other and solve. So we can write down negative x is equal to 1. And then we can come in and say we want to solve for x, so we want to divide by negative 1. And so x would equal negative 1. So log base 1/2 of 2 is equal to negative 1. Okay, let's look at part C. Part C, again, we're going to start the same way. We're going to set it equal to x. We're going to write it in exponential form. So we'll start with this pi, that's the subscript. We'll go to the other side and get the exponent. And we'll set it equal to the square root of pi. So we have pi to the x is equal to the square root of pi. Now remember, what power is equivalent to a square root? So we could do pi to the x is equal to pi to the 1/2 power. And so therefore, x would have to equal 1/2. So log base pi of the square root of pi is going to equal 1/2. Okay, what about part D? Log base 17 of 1. Let's set it equal to x. Let's rewrite it in exponential form. So start with your base, which is 17. Go to your other side. 17 to the x is equal to 1. So how is that possible? How can you take a number and raise it to a power and get 1? And the only way that can happen is if x is equal to 0. And so what we can assume then is that since the only way that happens is x is equal to 0, then we can say log base 17 of 1 has to equal 0. All right, our next one is log base 16 of 4. We're going to set that equal to x. We're going to put it in exponential form. So we start with the base of 16, go to the other side and get the exponent, set it equal to 4. So 16 to the x is equal to 4. Again, it's an exponential equation. Your goal is to try to write it with the same base if possible. So we could write 16 as 4 squared. We could write 4 as 4 to the first. So I have 4 to the 2x is equal to 4 to the first. Once your bases are alike, you can set your exponents equal to each other. And then you can solve by dividing by 2. So x is equal to 1/2. So log base 16 of 4 is equal to 1/2. All right, our last one, log base 10 of 1 over 100. Again, we're going to set it equal to x. We're going to put it in exponential form. So we start with our base of 10. We go to the other side and get the x. Set it equal to 1 over 100. So as an exponential equation, our goal is to write it with the same base. So that 100 can be written as 10 squared. And we know that we can move that 10 squared to the top of the fraction by making it negative. So we have 10 to the x is equal to 10 to the negative 2. And so therefore x would equal negative 2. So log base 10 of 1 over 100 is equal to negative 2. So keep in mind the steps that we have used here. We have set these problems equal to x. We have put it in exponential form. And then we have tried to write with the same base so that we are able to solve. All right, so moving on, let's try our next example. Solve the following equations involving logarithms. Log base 6 of 2x is equal to negative 1. So we're going to use the same approach here. The only difference is we're not going to set it equal to x. It's already set equal to negative 1. So we are going to put it in exponential form and see if that makes it easier to solve. So I'm going to start with my base of 6. Go to the other side and get the exponent of negative 1 and set it equal to 2x. So 6 to the negative 1 is, we're going to move that 6 down. So 1 over 6 is equal to 2 times x. All right, so now we need to divide both sides by 2 so that we can solve for x. Well, remember that 1/6 divided by 2 is going to be the same thing as 1/6 times, and not 2 over 1, but 1 over 2. So we have 1/12 is equal to x. Our next example says 3 to the log base 3x of 2 is equal to 2 power. I'm sorry, 3 to the power of log base 3x of 2 is equal to 2. Now, this is in exponential form. Even though it looks very messy and it does have a log, it is 3 raised to a power, and that power has the x, is equal to a number. So this is exponential form. So if we're going to convert, then we are going to be converting to log form. So let's see if that makes it any easier to work with. So if I convert it to log form, what's my base? All right, so the base is going to be 3. Remember that the exponent goes on the other side. So we're going to do log base 3x of 2. That's your exponent. And then the missing piece goes in the middle. Now this is just messy enough that I might like to go in and check and be sure that I've done this right. So I'm just going to kind of come off to the side here, do a quick check. Let's make sure. So we would have started with this base. We would have gone to the other side and gotten an exponent, and we would have set it equal to 2. So I'm just checking to be sure that I do have that set up correctly, which it does look like I do. All right, so let's look then at what we have. Now for these two things to be equal, they've got to be equal in all parts. So they both got to have the word log, which they do, and they both got to have the 2, which they do, and the bases have got to be the same. So how can we make a base of 3 equal to a base of 3x? So the only way that I can do that is if the x is equal to 1. And that solves that one. Okay, and our last one on that example, log base 2 of 8 to the x is equal to 5. We're going to put it in exponential form. It's in log form right now, so we're going to start with our base, which is 2. We'll go to the other side and get the exponent. And we'll set it equal to 8 to the x. So 2 to the 5th is equal to 8 to the x. And remember, your goal on these exponential equations is to write them with the same base. So 8 could be written as 2 to the 3rd. So we have 2 to the 5th is equal to 2 to the 3x. So how are those two equal? They now have the same base, so those exponents need to be equal. So we have 5 is equal to 3x. Divide both sides by 3. X is equal to 5/3. And that will complete that one. Now, the last thing that we really need to talk about here is we have a special case called the common log and called the natural log. So the difference is that a common log is going to have a base 10, and a natural log is going to have the base e. Okay, and most of the time if you're dealing with a common log, notice that it's written this way, and there is no base because the common log is what is assumed to be the case. So if you have a problem that does not have a base written on it, then the assumption is that it's a base 10. And note how the natural log is written. It's written as the ln of x. Again, there's no base, and it's a slightly different format for the log. And we have some properties that go with our natural logs. We have the property that says the natural log of 1 is equal to 0. We have the property that says the natural log of e is equal to 1. We have the property that says the natural log of e to the x is equal to x. And we have a property that says e to the natural log of x is equal to x. And we'll refer back to these, but in most cases, these are things that we can work out and not necessarily things that we definitely need to memorize. So let's look at a couple of examples here. We have 4 examples that we're going to deal with. All right, so the first one says that we have the natural log of the 3rd root of e. Okay, so we're going to solve this the same way we solved those earlier log equations. We are going to set it equal to x, okay? And we're also going to do a little substitution with this ln, okay? We are going to remind ourselves that an ln is really a log base e. So I am going to rewrite this thing as log base e, that's the ln, and then I'm going to do my cubed root of e is equal to x. Okay, and then we're going to put it in exponential form. So remember that you start with your base, which is this e here. You go to the other side and get the exponent. And then you set it equal to the part that's remaining. So that gives me e to the x is equal to the cubed root of e. Well, what is the cubed root of e as a power? Remember that that is the 1/3 power. So we have e to the x is equal to e to the 1/3. Therefore, x has to equal 1/3. All right, so you can conclude then that the natural log of the cubed root of e is 1/3. Let me get back to where I was. Okay, right here. So the natural log of the cubed root of e is 1/3. Okay? All right, so let's look at part B. Part B says log of 1,000. So remember that this is a log base 10 because there's nothing there. And we're going to set it equal to x. We are going to put it in exponential form. So we're going to start with the base of 10, raise it to the x power, and set it equal to 1,000. Well, remember that 1,000, writing it with the same base as of 10, we could write 1,000 as 10 to the 3rd. So we could say 10 to the x is the same thing as 10 to the 3rd, which this means that x has to equal 3. So the common log, log 1,000, is equal to 3. All right, our final two examples are examples that we should be using our calculator with, especially if we get a problem where we've got a decimal like this. This is not going to be something that I am going to be able to work out by hand. So on your calculator, you should have a button that says LN, and you're going to type it in exactly like what you're seeing on your screen. So LN, and in parentheses, you're going to do the 4.78. If you're doing it correctly, and you can email me if you're not sure, you should be getting 1.564. Same thing down here. You should have a button on your calculator that says log. So you're going to type that button, and then you're going to, in parentheses, put 10.5, and you get 1.021. And again, please ask me if you are not able to get those done correctly on your calculator.